Okay, what's a positive? 490. That's what I got too, so hopefully you got that. And a negative? Minus 230, right? Perfect. That's it. One positive, one negative. Okay, what about this? What if you got one positive and one negative coterminal with an angle of negative 1.3858? What units are that? Is that? It's radians, right? It doesn't say anything, so you know it's radians. So, how do you find one positive and one negative for this guy? I know a plus and a minus. Yes, it's always, okay, even though they give you decimals, you don't round to the very end, so you have to use the full 2. It's just plus 2 pi minus 2 pi. Not 6.28, because 6.28 is an approximate number. We want the exact number, and then you round at the end, right? If you use 6.28 here, that means you've rounded here, and then you're going to round here, right? We only want to round once. So negative 1.358 plus 2 pi, wherever your pi symbol is, right, equals, okay, 4.93 if I use 2 decimals, and then negative 1.358 subtract 2 pi. Oops. And I get negative 7.64. Agreed? Yeah. So this is your system here. It's either plus 360 or plus 2 pi. Okay. Okay. So that should be pretty straightforward. Coterminal. Like it's just plus or minus those. Sorry, those are my answers. 4.93 and negative 7.64. Okay. Now we're getting a little more into stuff that we're going to see, I think, more relevant things, to be honest, more valuable things for us. Now we know about standard position. For an angle in standard position, the angle between the terminal side and the closest x-axis is called the reference angle, which your book referred to. Any angle greater than 90 degrees has a corresponding reference angle. This means that reference angles are always positive and always less than 90 degrees. So that's really important to remember. Okay? So reference angles are going to be important in solving trig equations, which is what this is leading up to, right? We're studying all this intro trig stuff and learning about radian measure to do one big thing, is to solve equations, just like we have in every other unit. We learned about radical functions to solve radical equations. We learned about rational functions to solve rational equations. We're going to learn about trig in order to solve trig equations. Trig equations look a little strange because they don't have traditionally x's to solve for, they have angles to solve for. So that's why we're talking about all these angles, right? And I just want to stop for a moment because I want to show you what a trig equation looks like. You've done trig equations already. I know you have in grade 11. You've done what I would call a baby trig equation. Because has anyone ever seen anything like this before? Like sine of theta equals 1/2. And you have to solve for theta, right? How did you guys do that? You inverse sine it. Theta equals inverse sine 1 divided by 2. That's a trig equation. That's it. But we just build on that in grade 12. It doesn't get you know what else we do? This guy in grade 12 you'll be able to do without a calculator. This is called an exact value in grade 12. So some of you can do just from memory work in your head. Some of them are going to be a lot harder for sure. Like if I gave you something like this, sine theta equals, I don't know, negative 0.387, right? If I gave you it in decimal form, this isn't an exact value, but you do we're leading up to these types of equations. Right? We're going to do trigonometric trig equations, right? That's what we're leading up to. But they all involve solving for theta, right? That's what a trig equation is. So we kind of have to learn the basics of how to solve without a calculator again. We've got to learn that in trig, everything is very predictable because trig has those sine waves, right, that are very predictable. Once you know the max and the min of any trig equation or a trig function, you know lots about the trig function. Those max and mins will stay the same, the median values stay the same. So you can kind of get to know what the solutions to a trig equation is just by understanding a little bit more. But this is what we're leading up to, right? So it's all about the angles. So what we're going to do is going to learn a little bit more about those building blocks. So it says determine the reference angles for the following angles. Okay, I wish I would have left a bit more room here, but I think initially I think drawing a picture would help. Okay, so which is where our skill from yesterday, drawing those in standard position. So where would 95 degrees be? Quadrant 2, right? Just past quadrant 2, agreed? Wouldn't it just be about here? Okay. So what the reference angle is, I'm going to indicate in red. This is the theta. It says determine the reference angles for the following angle. Well, this is the angle itself, right? This is the theta they're talking about. Theta equals 95 degrees. But the reference angle to 95 degrees is over here. This is the reference angle. What would the reference angle be? It's the distance between the terminal arm and the closest x-axis.
85.
It's 85. Okay, how did you come up with 85, Eduardo?
180 minus whatever the angle is.
Yeah, so I don't know if you heard Eduardo, but he said how he came up with this. He did 180 subtract 95. And that gave you the reference angle. Okay? What about this one? 227. Where would 227 be? What quadrant? Quadrant 3, right? It would be, kind of over here. So, my theta equals 227. But my reference angle is just this little part.
47.
What did you say?
47.
So how do you know it's 47? I agree.
Take
Eduardo says it's the reference angle is 47.
your angle and then subtract that.
So how he got this one is 227 subtract 180, right? Yeah. Okay, so it seems like we should develop some kind of a system here, right? So I don't know what but if you think about it, if I just take my 4 quadrants, because my reference angle's or my terminal arm's gotta fall in one of these quadrants, right? So what's the relationship between reference angles and my x-axis? Okay, this is 0 degrees, right? This is 180. And then all the way around, it gets me to 360 again, right? And the reference angle is just reference to the x-axis. So I'm only worried about the x-axis angles. 0, 180, 360. So here the reference angle is going to be reference angle equals 0 plus the reference angle. If your terminal arm ends quadrant 1, the reference angle is just whatever angle you're given, right? That kind of makes sense, I think. Okay, here in this quadrant, the reference angle is going to equal 180, okay, minus, or sorry about that. The reference angle just equals 0 plus the angle given. I'm sorry, not the reference angle itself. Okay. Here, the reference angle will be 180 minus whatever theta is, whatever theta is given to you, which is sort of what they're calling the principal angle, okay? In this quadrant, and I'm going to explain it further in a minute. In quadrant 2, it's 180 plus whatever angle is given to you. And in this quadrant, the last quadrant, 360, do you think it's going to be plus or minus? Minus. Okay, I'm going to explain this again. Now, the reason it goes plus, minus, is if you think about it, just watch this for a sec. So if this is my quadrant system, use a different color. If my terminal arm ends in quadrant 1, okay? And remember, my x-axis is my reference point, right? That's how you define a reference angle, is the distance is away from the x-axis, okay? So if my terminal arm ends here, here's where my theta is. So I'm looking for the distance between 0 and the terminal arm, right? I'm moving in the positive direction, right? That's how I measure, remember how I measure angles? This is the positive direction. So if I'm moving from here to here, I'm moving in a positive direction. That's why it's my x-axis plus the principal angle. That gives you your reference angle. If my terminal arm ends in quadrant 2, here's my x-axis, right? If I'm trying to determine this distance from the x-axis, notice I'm moving in the negative direction. This is the negative direction. That's why it's a minus here. If my terminal arm ends here, from the x-axis, I'm back to the positive direction. That's why I'm adding to my angle. If my terminal arm ends in quadrant 4, this is where my x-axis is. Guess what? I'm back into the negative direction, right? That's why you add to the angle, you take away, add, take away. Okay, and you're always using the x-axis to start with, right? In quadrant 1, the closest x-axis is 0 degrees. So it's 0 degrees plus whatever angle you're given. Here, it's 180 minus whatever angle you're given. Here, again, closest x-axis is 180 plus whatever angle you're given. Here, it's 360 minus whatever angle you're given. That's basically how you find your reference angles. Okay?
Wouldn't it be minus in the third quadrant? I mean, if your angle is, let's say, 227, and then we add 180 to that, the reference angle would be like 227 plus 180, right?
Okay.
Wouldn't it be the difference?
What did I do? 180 minus the angle you're given, right?
Yeah. And like for the bottom one, it's just
360
theta
minus.
180. Like for the third quadrant, would it be theta minus 180?
Yes. Thanks in order. Theta minus 180. Right? Let's screw that up. 360 minus theta, right? Theta plus, let's try this.
Yeah, because like just put a number value to
Yeah.
it and try it out. You know what I mean? Like say theta is.
Let's try this one.
No, it's plus. 180 plus theta.
You know what's supposed to be?
Yeah.
Yeah, then we're gonna find the difference in
Yeah. Okay, let's try this one. Okay, let's say my reference angle is, let's say 240, okay? Or sorry, my angle given is 240, okay? My reference angle is going to be 60 degrees, right? So it's 240 minus 180 equals 60. So
Yeah.
it's principal angle minus 180 equals theta r.
Yeah.
Here, right? This is, so here, let's say my angle is 150. 180 minus 150 equals theta r. one, if I have 50 degrees, well, 0 plus 50 is 50. Okay, so this is good. This one, if I have 330, 360 minus 330 is 30. Okay, so it's 360 minus theta, 0 plus theta, 180 minus theta. Try to make this work. I guess theta minus 180. Right? Wish I could make it look better. Okay, let's see. So 0 plus theta, 180 minus theta.
Like if we do 180 plus,
Yeah.
it'd be the difference till 360, wouldn't it? Or
Yeah. Okay, sorry, let's do, I'm going to switch these guys. 180 plus theta r is, 180 plus theta r is, okay, never mind. All right, theta r equals theta minus 180. Right? Plus, minus, what did I wanted to have a nice pattern for you guys. Plus, minus, theta plus 180, theta r plus 180 equals theta. Right? Theta plus 180 equals, right? Sorry. Theta r plus 180 equals theta, but it's not solving for theta for you. So it's got to be theta r equals theta minus 180, right? So it's got to be plus, minus, minus, minus. It's harder to explain than to do, right? Okay, this is not a good day for me. I wanted to explain it a different way for you guys, but anyway, have I thoroughly confused you? No? Okay, let's try this one. Let's try negative 38. Where's negative 38?
northwest.
Nope, fourth quadrant, right? Okay, so here, negative 38. If you don't need a system, don't use a system, right? What's the reference angle? 38. Agreed? So the reference angle is always positive and always less than 90 degrees, right? So the reference angle is just 38. Oh, I guess we're going to make our own up here. What about this one? 4 pi on 7. Where's 4 pi on 7? What quadrant is it? Second, right? Okay, how do you know it's the second quadrant, Adam? It's more than half,
But not
but less than full. What would a full, this is where pi is, right? Okay, so in this case, you could think of pi as being 7/7 pi, right? If I'm talking, if they gave me sevenths to work with, then this would be 7/7 pi. Agreed? I'm only thinking of it at 7/7 because they gave me sevens to think about. So if this is 7/7 pi, as Adam said, 4 is a little bigger than halfway, right? So it would be about here, I think, wouldn't it? About 4/7 pi? Okay, well, what's the reference angle then? What's the leftover? 3/7, right? Yeah, okay. So would you agree with me, Johannes, that all the way around is 1 pi, right? Okay, so because they gave me 4/7 to deal with, if they're talking, they want to use sevenths instead of just a full number 1. So what, I could record 1 pi as 7/7 pi, couldn't I? Okay, just for this one question, I could think of 1 as 7/7. Okay, so if halfway around the circle is 7/7, halfway around the circle, then a quarter of the way around the circle, this would be what? 3.5 over 7, I guess? So then 4 has to be a little further over. So 4 would be about here, right? 4/7? Okay, so then what's the leftover? It's the distance between here and here. So 7/7 minus 4/7. The leftover would be 3/7. So this little piece here would be 3/7. What about, let's do one more. What if I gave you this one? What if I gave you negative pi on 5 for f? What if I gave you that? What's the reference angle to negative pi on 5? Pi on 5, right? So negative pi on 5 would be down here. So that would be the reference angle, right? What if I gave you, let's do one more. I'll do this one too. What about, how about negative 3 pi on 5? So negative 3 pi on 5 would be more than halfway, right? So this is negative 3 pi on 5. So what's the leftover? 2/5, right? Positive. Oh, sorry. Thanks for help. Reference angles are always positive. Thank you. What about this one? Negative 2.49. So what quadrant would that be in? Negative 2.49, where would it end? Quadrant 1, 2, 3, 4? 3, right? Okay, so negative 2.49, this is negative 1.57. This is 14. Yeah, kind of half-ish, sort of, right? Okay, so here's my negative 2.49. What's the reference angle? Okay, I'm talking radians now. So this would be, how would I find the reference angle? Pi minus 2.49, right? Pi minus 2.49. So pi minus 2.49, 0.65.
So, excuse me, 2 by, I think 0.5, same, or almost,
Sorry?
that number, the one you did,
Here?
no, the last one you did, yes, that one,
Yep.
that number, 2 by divide 5, and the one you did 0.65.
So yeah, so I would say this is pi minus 3/5 pi, right? Which would be 5/5 minus 3/5. Which is 2/5. Okay, go take a break, 5 minutes or so, and then,